Welcome to Chibuzor Mathphysics. In today's video, I want us to look at the properties for eigenvalues of n by n matrix with lambda 1, lambda 2, and lambda 3. This should be 3 by 3 matrices. So we are looking at the properties for these eigenvalues of matrix A. This matrix A is an n by n matrix with 3 value. So we are looking at the properties of eigenvalues of a square matrix, and this square matrix is 3 by 3 matrix with lambda 1, 2, and 3. And I want us to look at these properties because the properties will help us to find the eigenvalues and its corresponding eigenvectors. And when we are not sure or aware of what is the eigenvalue of a matrix, it will be difficult for us to find its corresponding eigenvectors. So it is good for us to know what are the properties for eigenvalues, as these properties will tell us what we intend to investigate as we want to find eigenvalues and eigenvectors, and that will take us to also Hamilton theorem. So the first property that we might need to talk about, number one property, is that for eigenvalue, let's have that down, eigenvalue with let's say that we have eigenvalue ak with a kind of subscript ak. This is equivalent to lambda 1 with k, and then we also have lambda 2 with subscript k up to lambda n, lambda n. What we mean by lambda n is that it goes up to infinity, depending if you are asked to find a 3 by 3 matrix, is it 4 by 4 matrix, is it 2 by 2 matrix. Whatever the case might be, this is exactly what you are required to do, and this is what you need to understand. As we go into computations, you will understand how to use this property. Let us take the second property of our eigenvalue. The second property is that when we have eigenvalue with a kind of a scalar multiplication, let's call it RK, or let's say it is KA. This is what we call scalar multiplication. This will be equivalent to K. Let's say we have KA. We have KA. This could be just a minute. We'll have K lambda. We're going to have K lambda 1, and then we will have K lambda 2, have K lambda 2, have K lambda 2, just a minute, lambda 2, and then we have K lambda 3 up to let's say K lambda n. This is up to the last value that you might be given, which might go. Of course, we don't need to go to infinity. The third property of an eigenvalue is that in each eigenvalue, let's have this down. Eigenvalue, let's say we have A. This A is our matrix plus or minus ki. K is a scalar, I is an identity. So if you have this kind of property, what this means is that it is equivalent to lambda 1 plus or minus k, and then we have lambda 2 plus or minus k, and then we will also have lambda 3 plus or minus k. This will take you to up to lambda n, then plus or minus k. So this is exactly what we are talking about. The number 4 property for eigenvalue, would be for singular matrix. Let's have this down for singular matrix. So for singular matrix, let's say that if you are having a singular matrix, what this implies is that you are going to take the modulus. In this case, when we are taking the modulus of this matrix, we are simply required to take the determinant, and the determinant of this matrix must be equal to 0, of course, and this is mathematically equivalent to one of the eigenvalues. So we can say it is one of the eigenvalues, and this one of the eigenvalues must be equal to 0. So it must be equal to 0. So this also is one of the properties of eigenvalue. The number 5 property would be that for one square matrix, if one eigenvalue is equals to 0, then we say that matrix is non-invertible. You can watch the previous video so that you know what we mean when we talk about invertibility of a matrix. So it is a property of a matrix, and we say that for one square matrix meaning that it has the same number of columns and the same number of rows, so it is an n by n matrix. So we have n by n matrix. So the eigenvalue EV must be equal to 0, such that the matrix, this type of matrix, is non-invertible. Now, when you watch the previous video on when we talk about invertibility of a matrix, let's say that just for explanation, invertibility of matrix, you might be given a PA. This matrix must be equal to a kind of PB. So you need to introduce an arbitrary B. If it is a 2 by 2 matrix, let's say A, B, C, D. If it is A, B, C, D, this will, you call this to be your P, and let's say that our matrix A is given by 1, 2, 0, 1. So this is a 2 by 2 matrix, and you do matrix multiplication, and when you multiply this matrix, you will get a matrix D, and this matrix D is what you will use to find the inverse of this matrix in order to know whether it is invertible. So what we are talking about here is that n by n matrix, the eigenvalue is equals to 0, such that matrix is non-invertible, because if it is invertible, the eigenvalue must not be equal to 0. We have so many other properties for eigenvalues, and I will continue this video in the next video. Hope you have understood. You can pause the video at any point and try doing it yourself. Try to follow by computations in order to know what we mean by each of these properties. I remain your friend, Augustine Galagash.